Hi everyone, my name is Lydia and this is what I wish that taught me about econometrics and introduction. In the previous video, we saw attenuation bias in action. OLS estimates shrinking towards zero as measurement error increases. So now let's see the fix. We'll use instrumental variables on the wage2 dataset to recover the true education coefficient that measurement error was hiding. As again, setup and baseline, we're going to use the usual libraries, Wooldridge, ggplot, and we're going to use data wage2. We're just adding the library AER in here just because we're going to do a few more regressions and graphs. So initially, we're just going to have a quick look at wage2. The variables we're mostly interested in, as usual, are the log of wage, education, we've got IQ, and we've also got a few other variables that, as you will see, we will need to use later on as instrumental variables. The baseline that we're going to use for the OLS education, so with true education, is the wage on education, experience, tenure, whether Black or not, South, urban. And we're going to see what the true beta for this particular case is. So while everything runs, so the true education, the actual effect should be approximately 0.0665. Okay, now let's add measurement error to education. We've seen that done in the previous video as well. And we're just going to once again repeat the computation of the lambda from the theory, where we've got the variation in the x star divided by the variation of x star plus the variation of the sigma in here, so the error, which the error normally we can't really measure, but we've got the residual. Based on what we get in here is that the attenuated coefficient, so the computations give us a lambda, first of all, of 0.667. So the lambda would be multiplied with the true beta. So the attenuated coefficient now should look smaller than the original 0.6 that we saw, and indeed is 0.0443. Now, OLS with noisy education, and we can compare also ultimately the two. So we've got with the noisy education 0.0372, which is 44% below the true beta that we had earlier. Now, we're going to look into different instrumental variables because normally, as we said, when we have the classical measurement error, the coefficient will have to fall attenuated towards zero, but we would need an instrument for the noisy education variable. And the variable should correlate with true education x star. The relevance condition should be uncorrelated with measurement error V and affect wages only through education, so the exclusion restriction. We'll use two candidate instruments. One of them will be the knowledge for world work score, so a test of knowledge that correlates with actual education, but that should not directly determine wages beyond education. And the second instrument is going to be parents' education, because family education background clearly influences how much education someone obtains, but normally shouldn't directly affect their wages. Okay. So both instrument sets should be correlated with education, and we'll check whether this relevance condition checks out or not. The exclusion arguments, we just gave the arguments now. We seem to think that they are plausible. And keep in mind, again, they should normally always be defended. So let's run the regressions, first of all, and let's check what the results that we will see. We can clearly see education, like the correlation with mother education, for instance, or father education with actual education are 0.3 and 0.4. Correlation of the knowledge world work score also is positive in here. So let's look at the first stage for the relevance condition. And we see that the actual KWW, so the first world score, the knowledge work score is 0.1, and it is statistically significant. So it seems like relevance checks for that. We can run the 2SLS as well, so that we can save the beta for this case, and then we'll do the same exactly with the parents' education as the IV. For parents' education, so again, the relevance condition does check. Overall, the actual relevance and the arguments that we provided for the exclusion should work, and these should normally be acceptable coefficients. Now, in terms of like how relevant, you can also check, remember the F statistic for both cases, at least for the KWW earlier here, the F statistic that we got was bigger than 10. So it meant that we have a relevant instrument, and the same would apply even for parent education. Now, keep in mind, for both cases in the IV estimate, we are getting two numbers. We're getting the true education regression and the one with the noisy education. And we're going to check whether the IV moved the estimate back towards the true value. And normally IV won't perfectly recover the OLS with true X estimate because we're using real data with real imperfection, but it should move meaningfully in the right direction. Okay? So with that in mind, even though the two are both relevant, there will be differences. And if both the IV estimates are similar, it means that will be reassuring because it suggests that both instruments are telling consistent stories. But we also have to be a little bit skeptical and careful about what we use. So we're also going to see the Hausman test in work as well. So let's do like the full comparison first with those. So as we can see in the OLS with true education, so that was the benchmark 0.06. With OLS noisy education, it was definitely attenuated and 0.03, with the lambda being 0.043. Now, with the 2SLS, in the case where we have the KWW as the instrument, we get that the beta is 0.11. With parents' education, we see that is 0.12. Okay, so clearly, we see that it has recovered, but keep in mind, as we said, we're using real data with real imperfections, so it should move in the right direction, but it doesn't mean that we will perfectly recover what we have. If we look at a visualization of the comparison in here for all of the case scenarios that we have, as you can see, we've got the true OLS in here, the one with the noisy, it's definitely a lot lower, the bar here. So we are overall like going towards zero. With the 2SLS, it seems like we are bringing it towards the truth, although it sort of shoots a little bit higher in terms of values. Let's look for the Hausman test now, because the Hausman test asks, is education endogenous? And in this simulation, it should be, because we added measurement error ourselves. We are going to check at the F statistic if the instrument is strong enough, if the F is over 10. Keep in mind, the IV fix that we saw in here, the instrument should have filtered out the measurement error, and it should have pulled the estimate back towards the truth, which is a little bit what we saw. For the Hausman test is more like a second way of making sure that indeed this is what happened. And with OLS and noisy education, again, we have the attenuated. With 2SLS, it's closer to the true effect. And it seems indeed that the instruments that we have in here have filtered out the measurement error. So the pattern is clear overall. So OLS with noisy education undershoots the true effect. IV pulls it back, not perfectly, but meaningfully. And notice that the theoretical prediction for beta times lambda is very close to what OLS with noisy data actually produced. So the formula works. In a real application, clearly we wouldn't know the true beta or lambda, so we'd only have the OLS estimate and the IV estimate. The fact that the IV, as we can see here, overshoots, so it's bigger than the OLS, is a diagnostic because it suggests that measurement error was attenuating the OLS coefficient. So in R, the 2SLS with a valid instrument recovers more of the true education coefficient than the OLS with a noisy measure, confirming like IV is a practical fix for measurement error in the explanatory variable. With this, we complete the measurement error mini arc. We've seen the problem from every angle: intuition, derivation, worked example, simulation, and the IV fix. In the next arc, we're going to look at the non-random sampling and another way that real-world data can lead OLS astray. So stay tuned, and I'll see you then.